Hello students, welcome to the channel. In today's video, we'll look at advanced trigonometry on the ACT. I've picked up questions from question 40 to question 60 of all math tests since the 2018 April test. And from that analysis, I have discovered that trigonometry, specifically advanced trigonometry, is the second most repeated question type. So today we'll look at the kind of questions that you can see from this topic. The first is sine rule. Sine rule states that in any triangle, let's say ABC, the notation is that the side opposite angle A is denoted by small a, the side opposite angle B by small b, and the side opposite angle C by small c. The sine rule states that A over the sine of angle A is B over the sine of angle B, and that is C over the sine of angle C. So this question here, the figure below shows a flying kite. At a certain moment, the kite string forms an angle of elevation of 75 degrees from point A on the ground. At the same moment, the angle of elevation of the kite at point B, 250 feet from A on level ground, is 45 degrees. What is the length of the string, right? So in this triangle, let's say the kite is point K. So in triangle ABK, we can find angle K by using the fact that the sum of the angles is 180. So 75 plus 45 plus angle K is 180. So angle K is 180 minus 120, which is 60. So this angle is 60 degrees. And now if the length of the string is x, then we can use sine rule in this triangle to get the value of x. Let me write here. So we have x divided by sine 45, because the angle opposite the side is 45, is 240 divided by sine 60, because the angle opposite 240 is 60. So x divided by 1 by root 2, since sine 45 is 1 by root 2, is 240 divided by root 3 by 2, since sine 60 is root 3 by 2. So x is 240 divided by root 3 by 2 into 1 by root 2. So that's 240 into 2 divided by root 3 into root 2. This cancels and I get a root 2 here. And this 240 can be written as 80 into root 3 into root 3. So the root 3 and the root 3 cancels. And 80 into root 3 into root 2 becomes 80 root 6. So my answer is option B. Okay, let's go to the next rule, the cosine rule. The cosine rule gives you the side length of a triangle if you know any angle of the triangle. So again, let's say I have a triangle ABC, and this is small a, small b, and small c. So cos of angle A is given by b squared plus c squared minus a squared over 2bc. Cos of angle B is c squared plus a squared minus b squared over 2ac. And cos of angle C is a squared minus b squared, a squared plus b squared minus c squared over 2ab. So it's a pattern that you can see comes from the way cos A, cos B, and cos C are written. So in the figure below, the distance between two pairs of cities are shown, as well as the angle formed at Ewing, which is a measure of 127. Which of the following values is closest to the distance between Dearborn to Fergus, this distance? So if I apply the cosine rule, I can say cos 127 is 80 squared plus 120 squared minus x squared over 2 into 80 into 120. So 2 into 80 into 120 cos 127 is 80 squared 6400 plus 14400 minus x squared. Now cos 127 is given as negative 0.6. So let's put that in the left hand side and find the result on the left hand side. So 0.6 multiplied by 2 into 80 into 120 is 11520. So this is negative 11520. So x square would be 6400 plus 14400 plus 11520, and that's 32320. So x squared is 32320. So x would be the square root of 32320, which is almost 180. So the answer is D. Okay, let's move to the next one. Now there is a sine rule for area, which states that if you have any triangle ABC and you have A, B, and C, then the area of the triangle is half AB sine C or half BC sine A or half CA sine B. So it is half the product of adjacent sides multiplied with the sine of the angle between the sides. So what is the area of this? It would be half sine 60 times 6 into 8, product of adjacent sides multiplied by sine of the angle. So 2 cancels with 3, 24. Sine 60 is root 3 by 2. So 12 root 3, option J. Okay, let's look at the ASTC rule. The ASTC rule is used to determine the sine, cos, or tan of any angle, right? So we have 0, pi by 2, which is 90 degrees, pi, which is 180 degrees, 3 pi by 2, which is 270 degrees, and 2 pi, which is 360 degrees. So ASTC. In the first quadrant, between 0 and 90 degrees, all the ratios, sine, cos, and tan are positive. In the second quadrant, only sine is positive. In the third quadrant, only tan is positive. And in the fourth quadrant, only cos is positive. So let's say I've been asked to find cos theta when theta is between 90 and 180, right? That means theta lies in the second quadrant. And I can see that here cos theta would be negative. Now sine theta is given as 8 by 17. And I know that sine squared theta plus cos squared theta is 1. So cos squared theta would be 1 minus 8 by 17 whole squared, which would come to 17 squared minus 8 squared by 17 squared, 289 minus 64 by 289, which is 225 by 289. So cos squared theta is 225 by 289. So cos theta would be plus minus 15 over 17, because the square root of 225 by 289 is 15 over 17. Now, since theta is between 90 and 180, I would take the negative value, because in the second quadrant, cos is negative. So my answer would be negative 15 over 17, option D. Okay, the sine and cos identity. which we just saw, which is to say that sine square of an angle added to the cos square of the same angle is always 1. So this question asked you to find the correct equation. Now sine theta plus cos theta can never be 7 because sine theta is between -1 and 1 and cos theta is also between -1 and 1. So their sum can never be 7. Sine theta plus cos theta equal to 1 is not always true. It could be true for particular angles, but not always true. So this is wrong. This is 7 sine plus 7 cos is 14, which is to say sine theta plus cos theta is 2. Again, that is not true. Sine squared theta plus cos squared theta is not 7, it is 1. So using the sine and cos identity, we get K as the answer. Okay, then you're also tested on the graphs of the sine and the cos function. And while the general graph is given as a sine bx plus c plus d, or a cos bx plus c plus d, for the purposes of ACT, you should only look at a sine bx or a cos bx. Now here A is the amplitude of the graph and B determines the period of the graph. The period is given by 2 pi over B. So let's say I have to find the correct graph, the correct cosine graph from these options, right? So I notice that the amplitude here is 3, right? So I know that A is 3, which means that I can cancel F and G. And what about my period? My period goes from here to here. And this point is simply pi. So my value of B would be 2 pi over pi. B would be 2 pi over pi since the period is pi. So B would be 2. So my right answer would be 3 cos 2x. 3 cos 2x because A is 3 and B is 2. Option K. Okay, then you need to remember the formulas for sine A plus B, sine A minus B, cos A plus B, and cos A minus B. Sine A plus B is sine A cos B plus cos A sine B. Sine A minus B is sine A cos B minus cos A sine B. Cos A plus B is cos A cos B minus sine A sine B. And cos A minus B is cos A cos B plus sine A sine B. So here you were asked sine A cos B plus cos A sine B. So that would simply be sine of A plus B, which is sine 60 plus 30. So that's option J. And obviously sine 60 plus 30 is sine 90, which is 1. And finally, we have values for sine of an angle after it has rotated through a certain number of cycles. So let's say I again look at my trigonometric plane, 0, pi by 2, pi, 3 pi by 2, and 2 pi. So if I have to find, let's say, sine 2 pi plus theta, let's say this is theta, and sine 2 pi plus theta would basically go like this and come back to this same place, right? So this will be the same as sine theta. What about cos 2 pi plus theta? the same. It would go all the way around and come back. So this is cos theta. Let's look at sine pi plus theta and cos pi plus theta. If I look at sine pi plus theta, then I come here, right? And remember the ASDC rule. So when I do sine pi plus theta, I get sine theta, but I get with a negative sign because in the third quadrant, sine is negative. Similarly, when I do cos pi plus theta, I get cos theta, but again with the negative sign because in the third quadrant, cos is negative. So the general idea is that whenever I add to theta a cycle of pi, right? So pi, 2 pi, 3 pi, any multiple of pi, I get the same ratio. I get sine when I add it to sine, I get cos when I add it to cos. But the sign may depend on which quadrant my final angle lands in. When it was pi plus theta, it landed in the third quadrant, and so sine and cos became negative. When it was 2 pi plus theta, it came back to its original position, and so they did not change. So this is something to remember with respect to the ACT trigonometry questions. Hope this exercise was useful. Hit like if this helped and subscribe to the channel to receive notifications of future uploads. Let me know in the comment section what other videos you'd like me to upload. I'll see you guys soon. Take care. Bye-bye.